Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 4 to the power of n minus 8 to the power of n is equal to 2, and we will solve this problem for the real values of n. So the very first thing we are going to do is here first we will discuss an important exponential law, and you know about this exponential law. If we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m is equals to a to the power of m times of n. So this exponential law tells us that if you can interchange these two exponents, here you have m to the power of n, or here you have n times n to the power of m, so it cannot be effect on the final answer, which is a to the power of m times of n. So now first we need to apply this nice exponential law. So now here I can first rewrite this equation as here you have 4 to the power of n, so we can write it as 2 to the power of 2 and its whole power n, minus here you have 8, you can write 2 to the power of 3 and its whole power n is equals to 2. And now we can apply here this nice exponential law, and we will just interchange these two exponents, and here we can interchange these two exponents, so that you can get the output in the form of 2 to the power of n and its whole squared minus 2 to the power of n and its cubed is equals to 2. And now here we need to simplify this equation, or here we need to convert this exponential equation into the cubic form, so that here I can just take y is equals to 2 to the power of n. So when you can put y is equals to 2 to the power of n, so that this nice expression will becomes in the form of y square minus y cubed, and now we move this 2 in the left hand side and you get minus 2 is equals to 0. And now we can rearrange the terms, so that in order to rearrange the terms I can multiply it by minus 1. So when you multiply it by minus 1, you get y cubed minus y squared plus 2 is equals to 0. And now in the next step I can rewrite this equation as y cubed minus y squared plus here you have 2, and I can write it as 1 plus 1 is equals to 0. And now we make the pairs of y with 1, and you get y cubed plus 1, and we can take common minus 1 from these two terms, and you get minus times of y squared minus 1 is equals to 0. And here I can write this 1 as 1 cube and this one as 1 square. So now here I can apply the two nice formulas. So the first is cubic and the other is the squared formula. So I can write it as, if you have a cubed plus b cubed, it is equals to a plus b times of a square minus ab plus b square. Similarly, here you have another formula, which is a squared minus b squared is equals to a minus b times of a plus b. So that here I can first use the cubic formula in this term, and after that we can use this square formula in the other term. So here you have y cubed plus 1 cubed, so it will becomes y plus 1 times of y squared minus y plus 1, and here you have minus sign, and minus times of here you have y squared minus 1 square, so this is, we can use here this formula, and you get y minus 1 times of y plus 1 is equals to 0. And now you can focus on both of the terms, and you see that here we can take common y plus 1 on both of the terms, so that you get y plus 1 times of y squared minus y plus 1. And now we multiply this minus on both of the terms, so that you get minus y plus 1 is equals to 0. Now we simplify these two terms and you get y plus 1 times of y squared. Here you have minus y and minus y, minus 2y, and 1 plus 1 is equals to 2, and whole is equal to 0. So here we have two cases. The first case is we take y plus 1 is equal to 0, and the other case is we take y squared minus 2y plus 2 is equal to 0. So in the first case you get the value of y is minus 1, and now here we need to back substitute the value of y, and in the start of the question here we take y is equals to 2 to the power of n, so that we will back substitute the value of y here, and you get 2 to the power of n is equals to minus 1. And here you focus on both of the sides and you see that this is exponential function, and you know about this exponential function, it cannot be gives us the negative value. It is always positive and its right hand side is negative value, so it cannot be possible an exponential function is equals to negative value, so that we will rejected this case. And now we can check this case if this quadratic equation has real roots or not, so that here I can use the discriminant formula in order to check this equation has real roots or not, so that here we have a is equal to 1, b is equal to minus 2, and c is equals to 2. So that our discriminant formula is delta is equals to b square minus 4 times of ac. So now I can a little bit explain this discriminant formula. You know that if this delta is less than 0 or gives the value of is less than 0, then we can say that this quadratic equation has no real root. So I can just write it has no real root. Similarly, if this delta or gives the answer or value greater than 0, then we say that it has two real root. And if this delta gives the values equals to 0, then we say that this quadratic equation has one real root. So now we check the behavior of this delta by putting the values of a, b and c in this delta, so that here you have b square and the value of b is minus 2 square, so it will becomes plus 4. Minus 4 times of a is 1 and c is 2 is equals to delta. And now you find its value is 4 minus 8, and 4 minus 8 is equals to minus 4. So here it is less than 0, so it means that it has no real root. So in this question has no real roots, so that here I can say that the given question does not have a real root or does not exist the solution of the given equation, because both of the cases will be rejected. This case is also rejected, so we say that the given question has no solution. So this is our final conclusion, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.